Ever wondered how we can trace AI-generated content back to its source, or prove it's original? Today, we're diving into a groundbreaking advancement in AI watermarking, a critical tool for verifying the provenance of machine-generated content. Think of it as a digital fingerprint for AI art, text, and beyond. Let's start with the basics. Watermarking isn't just about hiding secrets. It's about embedding detectable signals into AI outputs to confirm their origin. But here's the catch. Traditional methods struggle with autoregressive models, which generate content step by step. These systems tokenize images or text into discrete tokens, but retokenizing the same output often scrambles the hidden watermark. It's like rewriting a recipe. Your secret ingredient gets lost in the process. This inconsistency is called reverse cycle consistency, RCC, failure. Researchers identified this as a major hurdle, but they didn't stop there. They solved it. First, they refined the tokenizer and detokenizer, the tools that convert content into tokens and back. By training these systems to preserve consistency, they created a more reliable foundation. Second, they added a watermark synchronization layer. Imagine a backup system that detects transformations like compression or cropping and restores the original tokens, ensuring the watermark survives. The proof: their method works robustly. Even after common attacks, like JPEG compression or neural purification, the watermark remains detectable. They even tested it on audio, proving its versatility. The results: a near-zero false positive rate, validated by rigorous mathematical analysis. This isn't just about tracking AI art. It's about accountability. As generative models grow more powerful, tools like this ensure transparency, whether combating deepfakes, protecting intellectual property, or verifying academic work. Want to see how it works? Check the code link in the description. And if you're curious about how AI generates images or text, hit that subscribe button. We've got more videos on the science behind the magic. But here's where it gets even more fascinating. What if we could combine multiple data types, like text and images, to make watermarks even more powerful? Enter joint watermarking. Researchers tested this by training a model called Chameleon to generate both text and images from the same prompt. They embedded watermarks in both modalities and tested detection under real-world conditions. They adjusted two key variables. 1. Text corruption, altering text from 0% to 60%. 2. Image noise, adding distortions with varying intensity. The results: when watermarks were strong, combining text and image data always improved detection. Even if one modality was corrupted, the other often compensated. For example, merging text with 28% green watermark tokens, a measure of signal strength, with an image having 26% green tokens boosted accuracy. Here's the math: increasing tokens, like doubling them, allowed researchers to lower the watermark's strength while maintaining reliability. In one test, 5-fold token expansion with a slightly reduced green ratio slashed the p-value, a statistical confidence measure, from 0.06 to nearly 0.01, enough to pass strict detection thresholds. Why does this matter? Think of it like a team sport. If you only check one player's performance, text, or image alone, you might miss the goal. But combining both creates a stronger, more resilient verification system. This approach could become the gold standard for AI transparency, as models generate richer, multi-modal outputs. So what's next? The researchers hope this sparks a new era of robust, cross-modal watermarking. And for you, stay tuned. This is just the beginning of a critical conversation about AI accountability. Hit subscribe for more deep dives into the science shaping our digital future. Thanks for watching. Let's keep the dialogue going. What do you think about AI watermarking? Drop your thoughts below.